Morning students, today we are going to solve a question from the topic of force and equilibrium in the subject of Mathematics Mechanics 1 A levels, and the statement of the question is a block of the mass 5 kg is placed on a plane inclined at 30 degree to the horizontal. The coefficient of the friction between the block and the plane is mu. It means this is a rough plane. Okay, when a force of the magnitude 40 Newton is applied to the block acting up the plane parallel to the line of the greatest slope, the block begins to slide up the plane. Okay, and the requirement is show that mu is lesser than 1 by 5 square root 3. Okay, first we should show all the forces on the system. So here will be the weight of the body act, now resolving all the forces along and parallel to the inclined plane. So here will be the reaction that will react perpendicularly to the plane. The factor 50 cos theta, and theta is 30 degrees, so 50 cos 30 degree will act downward perpendicularly to the plane. Here will be the factor 50 sine theta, and theta is 30 degrees, so 50 sine 30 degree will act downward parallel to the plane. So these are the forces which are acting on the system. So here you can see that R is equal to 50 cos 30, and definitely the body is actually moving up, so it means 40 Newton will be greater than the two downward forces. So also the force of the friction will also act downward, that is F is equal to mu R. So 40 minus mu R minus 50 sine theta should be greater than 0. Okay, now solving these forces. So from here you can see R is equal to 50 cos theta, and 40 minus 50 sine 30 minus mu R is greater than 0. So solving all these forces, putting the values in the equation, you will get this answer. Mu is lesser than 1 by 5 square root 3. The B part of the question is when a force of the magnitude 40 Newton is applied horizontally in a vertical plane containing a line of the greatest slope, the block does not move. It means the body will be in the stationary position, and here is the direction of the 40 Newton force that is acting. Show that correct to 3 decimal places, the least possible value of the mu is 0.152. Okay, first resolving all the forces on this system along and perpendicular to the inclined plane. So here will be the weight that will be the direction of the weight acting. Here will be the factor 50 cos theta or cos 30. Here will be the direction perpendicular to the plane upward, that will be the direction of the reaction. And now same direction that will be perpendicular to the plane will be of 40 sine 30, and theta is 30 degree. Okay, here will be the direction of the factor 40 cos 30. Okay, downward will be the vector F is equal to mu R, and also the vector that will be 50 sine 30. So two forces will be act downward, 50 sine 30. Okay, because the system is in equilibrium, so definitely R will be equal to 50 cos 30 plus 40 sine 30. So this is one thing. Here you can see R is equal to 50 cos 30 plus 40 sine 30. So solving these factors on the calculators, This will be the answer. And the second thing is the upward vector, that is 40 cos 30, will be equal to mu r, that is f, and 50 sine 30. So after resolving these two vectors on the calculator, you will get this answer. This is equal to f means mu r. So you will take this value equal to mu r, and r's answer is here. So you will put the value of the r here, and after solving you will get this answer. So this is the minimum value of the mu. So mu should be greater than or equal to 0.152. So this is the answer. Thank you so much.